So let's talk about another 3D object called as cone, another topic of mensuration. And cone, pretty much everyone has seen it, and at least they like this format of cone, which is ice cream, which everyone loves. Another format is this, just as some of the examples. So let's try to see in this topic how to calculate or how to measure the volume of a cone. So interestingly enough, it's a very easy way to measure. If you see this, if you can check out the sample video I've copied from YouTube. It's a small 2-minute video, but you can copy. But what in video they're doing primarily, you'll see there is a cylinder here, okay, a cylindrical glass, and they have a cone in the hand and they're trying to measure water. So if you see that, in essence what they're trying to do is this. Over here you have a cylinder and over here you have cones, okay. So the volume of, if you want to fill up this cylinder with water, and if you take 3 cones, okay, and if you measure 3 cones of water and pour in the cylinder, it will exactly match. That means the volume of 3 cones put together is equal to the volume of a cylinder. If you see from a color coding, this part fills the orange, this cone 1 fills this much portion of water, cone 2 fills this much portion, and the remaining portion is equally filled by cone 3. So a volume of any cylinder can be assumed, or is true, that it's equal to the volume of 3 cones, 3 equal sized cones. So that's the trick of that. So by virtue of that, you don't have to really remember the formula of a cone in specific. If you know the volume of a cylinder, which is very easy, you can calculate the cone. And this is what pretty much I have put here. If you see here, if you see the volume of 3 cones, this cone plus this cone plus this cone, or you can take the same cone and fill it 3 times, then you get a volume of a cylinder. And in a way, intuitively, if you see this diagram also, there is a cone inscribed inside there's a cone here. If you see a cone, there's a cone inscribed inside a cylinder, okay. This is as if a cone is inverted inside a cylinder, okay. And you can see how that's fitted. And you can think about, this is forming one shape of a cone, and this is kind of a second shape, and this is a third shape, kind of. You can see the 3 cones are fitted inside each other, if that helps you remember that way. So in the exam, whenever you're forgetting the formula, all you have to remember is 3 cones make a cylinder, and this is how it's inscribed. And by virtue of that, what we're trying to say is volume of a cylinder is 3 times the volume of a cone, okay. That's what we're saying. In other words, if I flip this equation, volume of a cone is equal to 1/3 the volume of a cylinder. Whatever is the volume of a cylinder, if I divide it by 3 equal portions, I get the volume of 1 cone, right? And that, like that, we'll have 3 cones. And this diagram captures both the parts. If you see here, there is a cone inscribed inside a cylinder this way. So you can think about this cone 1, this is cone 2 kind of inverted, and this cone 3 inverted. So one cone is in this direction, and other 2 cones are in this direction with the vertex down, something of that sort. And if you look at this figure, right, so what you can think is, okay, if I want to calculate the volume of a cone, and I know that it's going to be 1/3 cylinder, so, and you can think about the cone inside a cylinder. So for that, I need to calculate the volume of the cylinder first, which is this blue part. Whatever is the blue part, the whole blue part is a cylinder, whichever is in this shape. If I checked out my earlier video of a cylinder, I've calculated that. So whatever is in this shape over here, okay, there's a circle on the top, there's a circle on the bottom, and there's kind of rectangular curved area over here. That's a cylinder, all in the blue shape, right? And we know that volume of any 3D object in its entirety, not kind of a section of this like a cone, but in its entirety is nothing but area of the base multiplied by height. We know that because in the case of cylinder also, we have not memorized the formula, we have just learned how it works. And the area of the base is a circle. We know that the top and bottom are circles. Area of the base is going to be pi r square and multiplied by this height, okay. That's the volume of the cylinder. This is what is written here, volume of the cylinder, pi r square h. And I just need to take 1/3 of that, or pretty much divide it by 3 to get a volume of the cone. So you simply divide this whole unit of area of the cylinder divided by 3. That should give you the volume of the cone in cubic units. Always write the units, whatever is the given units, whether centimeters, meters. If nothing is given, just write cubic units. And that's what is kind of put in a perspective in this figure, where the blues, all of the blue is a cylinder, which is pi r square h, all of it. And there is a simple cone inscribed inverted inside a cylinder, and we know that the volume of that one cone is going to be 1/3 of the volume of the cylinder, which is pi r square h. and that's how you remember the formula for volume of a cone. Okay, and in closing comments, no need to memorize the formula. Just remember the hint that cone is related to cylinder. Like I told when I introduced cylinder, learning cylinder is useful. For some reasons, textbooks skip cylinder in the end, but if in the 3D objects, if you learn cylinder, and cylinder is very useful to learn all the other 3D objects like cone, even sphere, and even semi-sphere. All these are related, and we can see that all of them are interrelated. But if you remember one, you can kind of derive the volume and the surface area for other 3D objects easily. So remember that. So cone is related to cylinder, and what is the relation? The area of a cylinder is given by area of the base into height. This is the measurement, and if you just divide this whole thing by 3, which is I've written, divide the formula for the cylinder by 3, that should give you volume of a cone. And that should be a wrap up on this topic, and we can move on to the next topic.